Hi, thank you for coming. My name is Gaurav, and I'm part of the professional services with VMware. Uh, Prior to this, I'm currently a consultant with VMware. Prior to this, I was with GSS, which is again VMware support. So let's get you started with the SSL certificates. Uh, I'm gonna talk about this into three sections, which is like I'll give you a generic overview about introductions to certificates, so that you have a deep agenda or like an understanding of how certificates works and what do I need to keep in mind, followed by how do I apply that particular knowledge into VMware components. Obviously, we cannot cover all of them, so I picked about 3 to 4 products with different variations. And finally, I'll give you a quick tip about how can you troubleshoot specific certificate issues. So basically, starting with, again, what is a certificates? So SSL certificates are small data files that digitally bind to a cryptographic key to an organization details. The certificates actually is something that gives you the padlock. So you have the padlock, you click on the lock, and you see the certificates. Those are basically certificates. And this is about a 30,000 level view of certificates. Now, we can use certificates in various scenarios. You can have basically a client to server authentication. You can have server to client authentication. You can allow the algorithms to be exchanged. You can the scenario that I'm really interested in is it gives you a encrypted SSL connection, and that's how you are sure that you are not being sniffed for now. And yes, you can generate certain shared secrets as well. So what's in a certificate is something that we would explore one by one. So DN is basically the domain name that we have for the certificates. It can be targeted to vmware.com. It can be targeted to me. So that's the DN that the certificate will have. It will have a public key, which is basically, you cannot just look out the public key. It's kind of a what we say, in an encrypted format. But yes, if you would like to look at it, you can open the certificate and look through the public key. Then there is a random serial number. I would not say random serial number. This is the serial number which comes along with a particular vendor. A DigiCert gives you some serial number, then it tags along with the customer, and it gives you a combined bigger serial number. That's something it is in the certificate. Then you have the digital signatures from any vendor. Let's say a DigiCert, GoDaddy, they'll digitally sign your certificates to make sure you have their trust. Now, if you look through the certificates in detail, so a typical certificate, you go ahead, double click those certificates. There are top primary fields that I have segregated that you should look for to make sure you are heading into the right direction or you have got what you need. So first of all is the version. So basically the first version would be, you will see V3, not V2, because V3 is more secure, and nowadays we use V3. And then followed by the serial number and signature algorithm. You will see SHA-1, SHA-2, SHA-256. Now you would be more or less seeing SHA-256 more often. And then you have the issuer, again the CA name, and the validity period. You can get a certificate for 1 year, 2 year, 3 year, depending on your CA and your organization. If you are building your own certificate authority within your organization, you will have to assign a validity period. It is not valid from 10 September. You cannot apply those certificates before 10 September 2017, and it is valid till 10 September 2018. So you have to reach those validity period. It clearly defines in the certificates. And then the most important one is the subject name. So subject name might vary. We will talk about what is the subject name and how does it vary from a certificate to certificate. Now, the major field of subject name, this will include your server name, maybe view.vmware.com. That's your subject name. You can apply those certificates to that particular domain. Then you will be able to, you cannot apply those certificates in certain situation to a different server. We'll talk about that going forward. And then obviously you will have the public keys. So why do we have the public keys and the private key? So these are, again, mathematical computation that will happen. It is not easy to crack. Public key is something that is available to anyone, to anyone who is using it, it's available. But private key, you have your private key, so you need the private key to decrypt the data. And now I will categorize among various certificates. This is again, I would say, if you are from the design field, it is one of the design decisions. If you are a customer, it is again a decision that you might have to look through it. Cost, complexity, various functions. But I have categorized into 3 fields. First is the digital certificates with the host name. When I say the host name, now if you would like to get a certificates, you can have multiple options in it. You can have a hostname based certificate. That means you take certificate just to apply to one particular server. That's view.vmware.com. You cannot take that certificate and go and apply to vra.vmware.com, nsx.vmware.com. You cannot do it because you took certificate just with one host name. You might have taken it from a CA, and there are again different costs for different behavior, or different vendors will charge you, but it depends. Now, if you have a smaller infrastructure and you want to secure just one component, and that might be only your external component, you are okay to secure the rest of the internal components using your own certificates, or maybe with the default certificates, you got yourself covered. You need to buy just one certificate, that would be the host name certificates. But for smaller environments only, the environment grows, your need might vary now. So it is ideal for just one, then you might want to buy 2. You get into a complex situation. You just bought a certificate for one server, then you want to buy for 2, then you need to maintain those all, maybe 10 components. It becomes difficult. It is not something that I would recommend for a larger environment. But again, security policies might change. I have a customer, and I pretty much have a lot of customers who would say, I cannot do alternate names, I cannot do wildcard certificates. So that's the only choice. And we end up paying so much for different certificates. And it's not only about the cost, it is about the complexity. Now you have to maintain so many folders within it. It becomes really complex. The second option is the alternate name certificates. So when I say alternate names, what do I mean by that? Basically, you get a certificate. This is, if you look at the first portion, subject alt name. This is one of the fields that would be published in your certificates. In subject alt name, you can define alternate names. You can get a certificate, maybe again for nsx.vmware.com. Now you define, or you start defining subject alternative names. Means this is my primary certificate, and these are my 10 alternate servers that I would apply for. They will allow you. Now every vendor gives you a certain limit, like a pack of 5, you can use only 5 subject names, a pack of 10, depending on how many alternate names you have, or the planning of alternate names. You can use this particular format, or this particular version of certificates. And the issuer has to match the complete name. And there would be 2 fields, like again, nsx.vmware.com. Now, if you want to have the short name for that, just NSX, you can have that. Third, which is pretty common, and it's good in certain cases if you are the only guy maintaining the complete infrastructure and you have to manage it end to end. Now you will get just one certificate. You apply to anything. So when I say anything, means you need the, of course, you need the key usage, you need all those fields, those are mandatory. But with wildcard certificates, as the name suggests, you can go with something like a star.example.com or star.vmware.com. Where would you be able to use it? logs.vmware.com, communities.vmware.com. You can use a wildcard certificate anywhere where you have that particular star.vmware.com. Now, vendor does not, they would not give you a 2-level digging. When I say 2-level digging, they won't give you a subdomain in it. So what would you have is, let's say it is a view.vmware.com again. You can have that certificate with, or you can have the wildcard certificates applied to this particular server. But if you have view.vdi.vmware.com, you cannot apply it, though you have a star.vmware.com. In that case, you would have to buy a star.vdi.vmware.com in that case. So just pay close attention to the subdomains and then choose the right certificates for your environment. Bigger environments, the only person managing the complete infra, the complete PKI infra, ideal for you. And now talking about how do I obtain a certificate. You can obtain a certificate from any external vendor. You can go with any external vendor, fill out those details, and you can get a certificate. You can set up your own infrastructure, your own PKI setup, go to a specific vendor and just get the digital signature. That way you're sure that your CA or the internal CA is signed. Or the third option, I have a lot of customers using it. Primarily this is okay for an internal only infrastructure, but when it starts to go external, it becomes quite complex. What you can do is you can still set up your PKI infrastructure, don't get it signed from anywhere. You can still continue to use it. You still have the SSL benefits, cryptography, or any encryption. You still have those benefits. You're just not paying for the external vendor just for the stamp, and it is still secure. But it's not a trusted certificate authority. So when I say a trusted certificate authority, I mean is most of the vendors, what they basically do is most of the browsers would carry those, at least the trusted root authorities. Even if you go to your Windows, you go to your MMC and open the certificates, you would see, oh, I have these trusted authorities already defined. So they are already pushed because they have been established and they have been pushed into it. If you want to use your own certificates, you might have to use a GPO to push it. I would not say it's manual or automated, but it is somewhat, you still need to speak to your AD team and then get those pushed to the certificate trusted authority. Now, digging into the actual process, now we know at this moment what are the certificates, what are the or what is the design decision to have the certificate being a host name or a wildcard certificates. We have all those decisions, right? Now we have to start the process. Let's start engaging a CA, or let's start engaging the within certificate authority to understand I need a certificate. Now, if you need a certificate, you might have to create a CSR file, which is basically a certificate signing request. You cannot fill out a simple template like a notepad. Oh, I need certificate for this server, and you just close it off and send it. No. You would have to follow a certain process. It will involve the key usage. It will involve the version number. So when you start generating a CSR, which is again an encrypted format, it goes to your CA or it goes to your internal PKI infrastructure. Once you deliver that, that is when he will generate, or he will be able to decrypt and provide you certificates based on the CSR file. He cannot generate the certificates based on your request of, I need a certificates on this particular server. You need to provide a CSR. OpenSSL is one of the techniques. Now with this section, we might spend about like 5 minutes to understand how do we create, or what are the various methods of generating the CSR. Most of you, I believe, would have been running into the CSR using the command line, using OpenSSL. You run the command and then you get the key output. Yeah, that's pretty much most of my colleagues still doing it. Now, apart from that, we have something like a Windows Certrec utility. Now, with Certrec utility, what happens is it's a built-in Windows utility. You can create or you can download your own request.inf file. A request.inf file is about what server name you have, what key usage, 2048, algorithm. You define all those. I'll show you a sample of a request.inf file. You just parse that request.inf file and then create a CSR out of it. That's again one of my favorites. I primarily from a Windows background, so I like the Certrec utility more than anything. Plus, it is simple. Now, if you would not like to still go via the command line, because first option OpenSSL is a command line, Windows tool is a command line, you have at least 2 to 3 other utilities available for you to just download them free of cost and run through the SSL certificates or the CSR generation step. When you start using a GUI based utility like DigiCert, let's talk about DigiCert. So you can, it's a simple tool. You download the exe file, you provide manual inputs to it. I have a screenshot added to it. You provide the inputs and it creates a nice CSR file. All you have to do is get the CSR file. You're done with step 1, which is our certificate signing request. Now, the problems with OpenSSL, again, it is powerful, but it's not easy to use. It is really powerful. It lacks documentation. If you run into trouble, you would end up spending like hours and hours just to try troubleshoot the problem. And that's how I, like maybe 3 to 4 years back when I was trying the OpenSSL, it was really cumbersome for me. I cannot simply, it gives me an error message. I go out and then there is an open source article. You go there and just keep looking for it. You end up spending hours and calling up support and then shooting in the dark. So that's how I had. But yeah, it is a very, very good utility, very powerful. Most of the open source operating systems have been integrated, and it has made its own advantages or its own benefits now. But I would like to go with the request.nf file. So this is the sample of a request.nf file. It is available on any of the, you can Google for request.nf file, and then you can request specific information. You can change the information that is available in this request.nf file. If you are looking at the last section, that is the SAN name, which is basically your subject alternative name. You can define various names using the same request.nf file. You can give your own subject name, friendly name, or anything you would like. You can make those modifications, run it back through certrec utility, couple of commands, and you should be good with the CSR file. Or you can choose the easiest way, which would be generate with the DigiCert utility. You download this DigiCert utility. If you are looking at the right side, you will have to enter just the manual commands, which is basically not even commands, the manual entries. Common name goes your name, subject alternative name, the names that you want as an alternate to a particular server, then your organization, department, city, all this information. The moment you click on generate, you're done with step 1. You have your CSR file ready with you. All you have to do is provide or proceed to the next step, which would be to a CA. You provide that to a CA signing authority or to your PKI infrastructure. Now, how do we proceed with the CSR? Now, let's say I have a server that I need certificates with. I've generated the CSR file. How do I proceed further? You can choose a vendor or a, let's say DigiCert itself. You go to their website, they will ask you or provide you an option to upload the CSR file. The moment you upload the CSR file, they will decrypt and capture all the information that you have manually provided and then issue a certificate based on your details or the details that you have provided. Now, typically it might take some time if you are doing it for the first time, because it goes for the background verification, because you are trying to get it stamped, you're trying to get authorized. So you have to fill in all the details. They will verify the authenticity, they will check, oh, this company exists, how long, they will check all those process, and then finally they will issue you the certificates. That would be the first time, and going forward you might do rekey. That would just work fine. Now we will upload the CSR, and let's say we are ready with the certificates. Now if you go to the URL where you have the certificates, you will see various formats. You will have the DIR format, base64, PKCS7, PKCS12. Now with all these formats, which one do you want to choose? It depends on your application. If I want to do it for Horizon, I would choose PFX. If I want to do it for NSX, I would choose base64. If I want to do for F5, I will again fall back to P7B. Depending on your application, whichever formats you would like, you can get the certificates for that format and download and use it, provided you have a private key intact with you. As long as you have the private key. So we discussed about public keys and private keys. Public key is available to the world. Private key is available only to you. Now, I was with support for about 3 years, and when I was troubleshooting the problems, half of the times it would be, I don't have a private key. I have the certificates, I don't have a private key. So where did my private key go in? So the private key would stick to the computer or browser from where you have created these certificates. So if you have created the certificates on a specific computer, the private key would stay on that particular computer, and then once you get the certificates, you can install or maybe import it via MMC or via DigiCert utility, anything. Once you do the import process, then that's a valid certificate. Now you have both of them. You have the public key and the private key only when you import it on the same machine where you have generated the CSR file. Now, this is how a typical digital certificates would look like. This is a screenshot of VMware.com. I went to VMware.com on the generic VMware.com, and on the right hand side, of course, left hand side is from a lab environment. I went through that, I clicked on the view certificate, and I see a star.vmware.com. If you look through it, star.vmware.com, even we are using a wildcard certificates. So, and this might be different for, or like this might be used in the blogs or wherever, but we are even utilizing a wildcard certificates. Now, let's talk about what we did in the past now. We generated the CSR, we gave the CSR to the CA, CSR gave us the certificates back. Now we have imported the certificates, we have the public key with it. Now let's run through a life cycle. What do we do with those certificates? Generic question. First was your enrollment stage. The moment you gave the CSR file, that was your enrollment stage. You have been enrolled to a specific vendor to get a specific certificate. Next is your renewal stage. So when you say renewal, you might have to renew the certificates once it is expired. Let's say you have taken it for 1 year, you would have to renew it the next year. And then if you have taken for 3 years, so that's the renewal stage. You will get nice little alerts or emails stating your renewal is due on this particular date. Third stage is revocation. Now companies also run something like a CRL or OCSP to check the authenticity of the organization. Let's say I am out of business for some time, and I don't use those certificates anymore. Your certificates would be revoked. Or let's say I have my private key compromised. If I have my private key compromised, that means again I have to rekey the certificates. So that's a revocation stage. So in a revocation stage, you might have to rekey or redo the entire process. Rekey is basically starting from scratch. So when I say starting from scratch, for an example, let's say I have a subject alternative name based certificates, and I have close to 10 subject alternate names and just single one subject name. Now I have another server requested, and my team is telling, okay, can you adjust the same server in that particular subject alternative name? My first answer would be no, because I don't have that particular FQDN defined in my certificates. So that would not work that way. So what I can do, the other option I can do is, I'll get the name, I'll redo the starting from CSR file, I'll recreate the CSR file. Once the CSR file is created, go back to CA and then get the certificates back. So this is the typical lifecycle management of certificates. Now we will try to apply those terms or the things that we just learned about 10 minutes back. Now if we have to apply the certificates to VMware components, now I picked up specific tracks. So when I say tracks, I picked up a product from EUC. This is a connection server. If anyone is familiar with the EUC portfolio, the connection server is kind of a connection broker. Now, why did I pick up connection server? The major reason of picking up connection server is it is not recommended to run connection server on default certificates at all. So when you install any of the VMware products, you will have by default the default certificates installed. Those are not secure, or I would say those are not recommended to go in a production environment. It will continue to give you an HTTPS with the red arrow on it, stating no, these are not valid certificates. because it involves so much of client-server communication, we recommend to at least apply certificates on the Horizon Connection Server. So once you apply certificates on the Horizon Connection Server, this is a sample format. You copy the certificate. The major requirement that we have is a private key exportable. The private key should be exportable for Horizon Connection Server. It's a very, very simple step. You go to MMC, you choose computer account, and then you import the certificates, provide the passwords, and restart the certificate, restart the connection server. Once you restart the connection server, you should have certificates. If you are looking at this process, one of the key requirements that we have with this is about the friendly name as well. The friendly name is VDM. So when I say VDM, if until and unless you provide the friendly name as VDM, you won't be able to restart the services. So, or I would say you won't be able to apply the certificates itself. In the MMC console, you would see two certificates. One is the default. You need to rename the default, and then the other one to VDM for it to work. Similar for Site Recovery Manager. This is the actual, I would say, the product, which is really simple to apply. You get the certificates copied. Once you have the certificates copied, you navigate to the certificate file, you browse it, click, provide the certificate password, that's it. Restart the services, it works just fine. Similar to this, we have for NSX. For NSX, if you haven't used it right now, or maybe you haven't seen it for now, NSX has the capability to provide you a CSR file. You can generate a CSR file out of NSX admin page itself. All you have to do is, again, you don't have to take any of the steps that we discussed. Just enter the details required, and you should have a CSR file. Go back to CA, generate the certificates. Applying certificates is via the command, via the GUI page, and that's relatively very simple. Now, here's a little tricky part about NSX certificates. The chain that it creates. So when I say chain, every certificate will have a specific chain to it. Now, there would be a root certificate, intermediate, and then the final certificate. So if you have to look through the chain, if you're following a 3-level hierarchy, that means you need the root, intermediate, and the actual certificates. Now you open those certificates in a text file, copy paste it, you can build the complete chain and utilize those complete chain. Then you will see right clicking on those certificates points out which certificates or which chain it is, what is the root and what is the intermediate to it. And last is the VRA. Now VRA is the most I would not say complex. It is just that you would have to follow the correct process. You need to do the certificates or replace the certificates on the identity appliance first, then to the VRA appliance, followed by the IAS components. If you don't follow the correct process, you might end up re-registering and redoing the complete activity, which makes it a bit complex. But if you follow the correct process, you should be fine. And apart from this, I would say a few things about troubleshooting SSL certificates. I think SSL troubleshooting is a bit complex. You end up spending so much time. I'll give you a couple of tips, or these are like my favorites that I use it in almost 99% of my customers if I run into a SSL issue. The first one is every product will have a specific log file. In the log files, it is very, very, very easy to spot authorization and authentication errors. Once you spot the authorization and authentication errors, it will clearly tell you subject name does not match the name in the certificates. Subject name does not match the name of the appliance. It gives you clear understanding, and then you can look through it. It makes your life easy. You can go back, CSR, same steps. Second utility is the CSR decoder. Now you can go to the sslshopper.com. If you haven't visited this website, you can go to this SSL Shopper website. You will see various tools to it. You have a CSR decoder. At times your vendor says, no, I gave you the right certificate. You can go yourself, decode the CSR and see, okay, what did I provide to them? And their own. You can also see if it is externally published certificate, you can simply enter the URL. It tells you what certificates is already applied, what is the validity. It gives you enough information for you to support. These two websites, or like these two things, if you follow the logs and the SSL checker, you should have enough information to troubleshoot further. You can always file a support request and seek help via VMware communities as well. I think that's pretty much of it from my end.